redox reactions. That's why I'll cover 9.1 really quickly, and then Randa inshallah she's gonna delve into 9.2. We'll give you some mnemonics, some questions مع بعض, and hopefully by the end of it you'll benefit inshallah. Okay, so which of the following, ooh, one second, was there a slide deleted? There has been a deleted slide. No worries. Yeah, okay. So, which of the following statements is correct regarding the reaction involving copper and iron? Now, so if I have copper and I have an Fe3+, what's going to happen? Redox is going to happen, but which one has a reducing potential, a greater reducing potential? Fe? Which one? ايه هو reducing potential اصلا؟ Gaining electrons. Which one of these is more likely to gain an electron? An Fe. So what will the ionic charge of Fe be?
0+2.
Okay. With copper?
+2.
Are we sure about this?
Yes.
For sure?
Say yes.
I mean, you are correct in terms of emission ionic distribution and such. But in terms of the reducing potential, yes, that is correct. Okay. In reducing potential نفسه is the reducing agent is the one that's going to gain the electrons. احنا في a really nice mnemonic to learn إنه oil rig. Have you heard of that before?
Yeah.
Oxidation is the
Loss
of electrons, and then reduction is the gain of electrons. Now there's also this table which helps you then not only look at electrons but also hydrogen and oxygen, because later on when we go into the coenzymes, can someone give me an example of a coenzyme?
CoA.
CoA. FAD. NAD.
NADP.
NADP. Perfect. Great. Yeah. NADH. Perfect. So that's it will between NADH2 and NAD+. Perfect. Great. So that's basically the table. So just remember, in electrons and hydrogen, the gain and the loss will be the same, whereas oxygen is going to be the opposite. Is that clear? Perfect. Yeah, let's go on to the next concept. So over here, what do we call this? Electrochemical cell.
Yeah.
So we call this the electrochemical cell. Now that you guys have this equation over here, can you try to see, is it correct or wrong? It is indeed correct. Yeah? So stick with your mesh. Perfect. So we call this the electrochemical cell. Now what can we say about the movement of the electron? Where is it going?
From Fe to C.
From
Copper to
copper to the iron. Because this is the one that's gaining the electrons. Perfect. So what determines the voltage or the potential difference in the electrochemical cell? Is it A, the concentration of reactants, B, the movement of electrons between half cells, C, the type of solvent used, L, the temperature of the reaction? B, last answer? Everyone's saying B? B is the correct answer. It is the movement of electrons between the half cells over here, always going towards the one with the greatest reducing potential.
I don't understand the diagram.
So the diagram over here, this is essentially two cells. Over here we have a copper solution, and here we have an iron solution. And then we have a voltmeter to determine the change in voltage. So what happens is that they're connected to each other, and what happens is that the copper, since it has a less reducing potential, it's more likely to donate electrons. Whereas the iron over here, which has a greater reducing potential, it's more likely to gain electrons. So what will happen? The movement of the electrons will move from the solution over here all the way to the other solution in order, depending on the reducing potential of the different ions. Does that make sense? Perfect. Okay, reducing potential. We went over it. Thus, what does it mean if a substance has a more negative reducing potential potential than H plus, proton? Is it A, it has a higher affinity for electrons than hydrogen? No. It will donate electrons to a substance with a more positive reduction potential? Will it donate? Or will it gain the electrons if it has a more negative reduction potential?
B. Will donate.
It will donate, indeed. If it has, so do you guys know what is the reduction potential of hydrogen?
Negative 0.46.
42. Yeah. Negative 0.42 volts. So that is the reducing potential of hydrogen. So what will happen if it has a more negative reduction potential? It's more likely to donate the electrons. Does that make sense? Perfect. And we talked about that. Okay. So I want you now to compare those two different ions now. So we remove the iron. We now have zinc. What's happening here? Who can explain? Who has the greater reduction potential? Where are the electrons moving towards?
To the copper.
To copper. So who has the greater reducing potential?
Copper.
Copper. Perfect. Who has the more negative? Zinc in that case. So you see how that flipped. Whereas when we had iron, who had the greater reducing potential? Copper or iron? Iron in that case. So the movement of electrons was the other way around. Does that make sense? Perfect. Now, over here, we're not going to talk about electrons, but now we're going to talk about, now think about hydrogen. احنا دلوقتي قلنا ان احنا عندنا oil ring, reduction and oxidation. Reduction is the gain of what? Electrons, and the gain of hydrogen and the loss of oxygen. Whereas oxidation is the other way around. So in this case, in the conversion of pyruvate and NADH to lactate and NAD+, which of the following is true about the redox reaction occurring under anaerobic conditions? So first of all, pyruvate, what has happened from pyruvate to lactate? What can you notice about the change in the structure?
Ketone group, alcohol.
Okay, perfect. And what has it also gained? Hydrogen. Now let's compare that to the NADH. Over here, our coenzyme. So what happened to the NADH? Loss of hydrogen. So which one got reduced? Pyruvate got reduced, and which one got oxidized? NADH in that case. So what's the answer? Pyruvate is reduced, NADH is oxidized. Perfect. Okay. Which of the following best distinguishes? Now, at the beginning we were talking about the different coenzymes. We said that FADH2, FADP, NADP, NAD. So what is the distinguishing factor between NAD plus and NAD plus? What is the distinguishing factor? Is it that NAD plus is involved in biosynthetic reactions and NADP is involved in catabolic reactions? No. Because NAD plus is involved in which types of reaction? Catabolic. Can you give me an example, which we're going to cover?
Glycolysis.
Glycolysis and command the Krebs cycle.
Citric acid.
Citric acid cycle, the TCA cycle, that's where we use NAD+. The NADP, where do we use that?
Biosynthesis.
In biosynthesis reactions and anabolic reactions. So what is the correct answer? C in that case is the correct answer. Well done. Okay, flavoproteins. You talked about FAD and FMN. Typically function as which of the following types of enzymes? Are they kinases and phosphatases? Or are they dehydrogenases, oxidases, and hydroxylases? Ligases, isomerases, hydrolysases, and transferases? B is the correct answer. Well done. Do we know why it's B?
Yes.
It's classified as these over here, and you guys have the table that includes the coenzymes, and we're going to go over that. What is the component in both FMN and FAD?
Flavin, adenine.
Riboflavin.
Yes.
Riboflavin is the vitamin that is included in there. Perfect. You guys have to memorize this beautiful table, right?
Not all of them.
Not all of them? Which ones do you have to memorize?
Thymine,
Thymine,
one of them,
yeah?
and pantothenic acid.
Nicotinic acid. None of them.
Yeah, one. And nicotinic acid.
Nicotinic acid, but you don't have to memorize CoA,
Also pantothenic acid.
CoA, biotin tetrahydrofolate. Perfect. أنا عايزة okay, in that case, let's go straight to the memory test. طب خلاص. NAD plus will NADH. Which one of these?
B.
Electron carrier in catabolic reactions. Correct. NADP plus and NADPH.
B.
You girls, you tell me. Where do we use them?
G.
G. Electron transfer in oxidation reactions. They're used in redox reactions. Yes. ماشي. Vitamin we can skip. TPP. TPP you said معاكم?
Yes.
Okay. TPP.
E.
TPP decarboxylation. هي الopposite بتاع بقى decarboxylation is carboxylation which is vitamin. But since you guys مش عليكم خلاص. And that's it. That's كل اللي عليكم. Perfect. And yeah, CoA is which one? Is what?
Transfer style.
Transfers الأصل groups. ممكن بدل أصل ممكن يستخدموا which word? Methyl group or methylation. So acyl, adding an acyl group, methyl group, or methylation. Does that make sense? Perfect. Any of these concepts before we move on to the TCA cycle you didn't understand in terms of redox, reducing agents, oxidizing agents, the coenzymes themselves. How are we feeling about those? Thumbs up? Thumbs up? Okay, خلاص, perfect. I'll now give it on to Rad to explain the Krebs cycle.
Okay. Hello everyone. So now we're going to talk about the Krebs cycle and we're going to try to help you memorize it and solve some questions. And let's begin. So the first question, we're going to start easy and we're going to get a bit harder. So what are the end products of the link reaction? Is it A, B, C, or D?
C.
C?
A.
A? So who agrees it's A? Everyone? Do you didn't agree? Do you have another answer? No? The answer is A. Okay? So we're going to do, okay, so the final products of the link reaction are acetyl-CoA, which is going to help us in the Krebs cycle, CO2 and NADH, tamam? So a quick revision to the link cycle. Why is it called the link cycle? Because it links glycolysis to the Krebs cycle, tamam? So as we know, in glycolysis, pyruvate is formed, and this pyruvate is going to undergo some changes to prepare it for the Krebs cycle, okay? So as we said, the pyruvate is basically going to undergo oxidative decarboxylation. What does this mean?
Oxidation and decarboxylation.
Okay, that's like what happens? CO2?
And oxidation, reduction.
Exactly. So there's going to be oxidation and decarboxylation, which is basically the pyruvate is a 3-carbon molecule, right? It's going to lose one of the carbons, which is going to be lost as CO2, to become acetyl-CoA, and it's also going to reduce the NAD+ to become NADH. So the pyruvate got oxidized to acetyl-CoA. That means now that it's ready for the Krebs cycle, right?
Yes.
Okay. So these are the final products, and let's move on. So glycolysis happens, what does that happen? Where in the cell? Cytoplasm. So now it's going to move and get transferred to the mitochondrial matrix. Exactly. There you go.
How many pyruvates do we have?
Two.
2 pyruvates. So that means from 1 glucose, how many times are we going to have this cycle? Twice, because we're going to have 2 pyruvates, which is 3 carbons and 3 carbons, and these are going to run twice in the cycle to give us the product of 1 glucose molecule. Is this clear? Tamam? If you guys have any questions, we can stop. Okay? So, what is the primary enzyme complex involved in the link reaction? Exactly. The answer is D. So, what do we mean? Okay, let's do this one first. So, what are the coenzymes required for the activity of the pyruvate dehydrogenase complex? Is A, B, C, or D?
B.
D? Do you all agree? Should I reveal the answer? The answer is B. Yes. First of all, we can eliminate A and D because they do not have NAD+, tamam? And we're going to refer to a table after that's going to also eliminate C. So the answer is B. And according to this table, okay, so first of all, we know that the pyruvate dehydrogenase complex, it's a group of enzymes, tamam? They're acting together on a substrate, right? So it's like, it's many pieces of a puzzle, you could say. We have the pyruvate dehydrogenase, which decarboxylates pyruvate. We have dehydrolipoyl transacetylase, which catalyzes the transfer of the acetyl group of the CoA in the link reaction. And there are also like other functions done by the enzyme, which we don't really have to get into. And these are coenzymes used in the Krebs cycle. They're also used, some of them are used in the link reaction, such as FADH2, NADH, coenzyme A, and TPP. Like, I don't know if you guys took this, but it helps some of the the enzymes you took it in the cycle. Which enzyme?
Alpha ketoglutarate.
Exactly. Okay? So, do you guys know what copy square complex means? This is basically how many substrates the enzyme can catalyze at once. So it can work on like 24 substrates to make products, okay? Alright, now we're going to move on to the Krebs cycle. Do you guys know why it's called the Krebs cycle?
Scientist.
The scientist who made it, and not made it, who discovered it, in 1937 he was called Hans Adolf Krebs. He discovered it and it was named after him. It's also called the citric acid cycle because the first product used is a citrate, okay? And it's called the TCA cycle, which stands for tricarboxylic acid cycle, because there's going to be 3 CO2s eliminated, okay? So, this question, which of the following is not a product of the citric acid cycle? A and B, exactly. And which of these products is not formed during the Krebs cycle? A, lactate. Do you all agree? Tamam? طيب. And I think this is the final question. D? Exactly. طيب, now we're going to move on how we can memorize the Krebs cycle effectively. Tamam? So as we know, the Krebs cycle is 2 stages and it's 8 reactions, right? So the first stage is basically releasing the carbon dioxide molecules. The second stage is regenerating the oxaloacetate, okay? So first of all, we're just going to go over it very quickly. Is there a pen that I could use maybe? There is a thing. So we're going to go over it very quickly, just to revise it before we can learn how to memorize it, okay? So in the first reaction, we now know that acetyl-CoA is going to come from the link reaction and combine with oxaloacetate to form citrate, right? This is the first product. Now this citrate is going to undergo isomerization, which means it's going to change its shape and become isocitrate, okay? Now these are going to what? 6 carbons, right? Like, now we're going to move on to step 3. Now in this step, it's going to use one of its carbons to become a 5-carbon molecule. So CO2 is released, and at the same time, NADH is made. So this is oxidative decarboxylation, right? So next, after that, we have the alpha ketoglutarate. It's going to undergo the same thing. It's going to use CO2. It's going to make an NADH. It's going to undergo oxidative decarboxylation to form succinyl-CoA. Okay? Now, this is also going to lose the COA. It's going to become succinyl-CoA. It's going to become succinate. And when this happens, it's going to form 1 ATP. Okay? And then, now, an important part about step 5 is that this is known as substrate level phosphorylation. Do you guys know why?
We got the phosphate from the substrate itself.
Yeah, so we're going to be using inorganic phosphate molecule, and this is going to combine with the succinyl-CoA to give us ATP, okay? So let's say, for example, they may ask you in the quiz or the exam, like which step in the citric acid cycle undergoes substrate level phosphorylation, okay? So this is going to be step number 5, where succinyl-CoA becomes succinate, okay? Now moving on, we have succinate, it's going to change to fumarate, and this is going to form FADH2, and then fumarate is going to be hydrated, so it's going to combine with water to form malate, and last but not least, it's going to release an NADH to become oxaloacetate. Now the oxaloacetate is regenerated, and it's going to keep going in the cycle, and the cycle keeps repeating, okay? So how are we going to memorize this? In the exam, how are you going to draw it out so you could easily solve the questions? Our issue, we have the first mnemonic, which is, can I keep selling seashells for money, officer? This is for the substrates. So we have, as we know, the citrate, acetate, and going on. The second mnemonic we're going to be using is cool aunts and cancers, sell special fudge monthly. This is for the enzymes, okay? So we're going to go through it, come out when we solve it. And last but not least, we have Dina Afana. So this one was brought by Jana, but this one is going to basically tell us about when is the CO2 and NADH when they're being released, okay? So let's start. I think I'm going to draw it on the board. عشان أسهل. Okay, we're going to draw it over here, تمام? So first of all, we're going to start with the first mnemonic. Here, can I keep selling seashells for money, please? صح? Let's just write them down to get the hint. أول واحد اللي هي can I keep selling seashells for money? I don't know if you guys get the handwriting, but you get the idea. For money officer, صح? طيب, so So what do we do first? The first one is a C, صح؟ So أول شيء حيكون عندنا اللي هو إيش؟ Citrates, right? This one comes from the combination of oxaloacetate and acetyl-CoA, right? We're going to draw them بالآخر. I'm just going to draw this one here.
Where did we get the acetyl-CoA from?
Exactly. طيب, so أول شيء we're drawing the substrates, تمام? Next we have the isocitrate coming from I, and then after the isocitrate we have the K, which is alpha ketoglutarate. تمام? Now, moving on, we're going to have selling, which is succinyl-CoA. And then after that we have seashells, which is succinate. And then after the succinate, we have F for fumarate. وآخر شيء we have officer that في money. So money is going to be malate. And last thing we have is oxaloacetate. صح? Okay. So it's a bit squished here, but you get the idea. تمام? This is the Krebs cycle, but we already have the substrates. صح? Now we're going to move on to what exactly happens. So this one, for the products that are going to be formed, we're going to be using the second mnemonic, which is Dina alpha na. Alpha na. Okay? Yeah. So, just شايفين? You guys see it? Okay. طيب.
Remember it بالرhythm دينا أفنا. So my bio teacher taught it to us this way, and it clicked, and it works.
Alright. طيب, so just to keep a tally عشان نتأكد إنه we're following the correct product, we know that NADH is formed, FADH2 is formed, CO2, إيش كمان what do we have? We have ATP, and there's a fifth product,
CO2.
CO2 مكتوبة. هيك خلص صح? Isn't it one? Okay. So first of all we have DINA. Now what does DINA stand for?
CoA. Also.
CoA. You could say this not exactly. It's just combined.
Because you release it from
Yeah,
Yeah, but it comes from the just comes like it's removed from the first reaction. So it's not really a direct product of the Krebs cycle because it keeps combining in the link reaction. It's a cycle. This is a separate cycle, and this is a separate cycle. Okay. So our issue, DINA stands for, so D is decarboxylation, which means CO2. And N is the release of NADH. So that's what DINA stands for. For our issue, we're gonna skip step number 1, which is the formation of citrate, and step number 2, which is isocitrate, because this is just isomerization, right? There's no products formed. Tamam? So first of all, we have DINA, which means that there's going to be decarboxylation, and NADH is going to be released, right? So over here, we're going to remove CO2, we're going to remove NADH. Let's keep a tally of how many products are being removed. Now moving on to the next step, which is alpha ketoglutarate changes to succinyl-CoA, we also have DINA again. So we're going to remove a CO2, we're also going to remove an NADH, all right? Now continuing in the cycle, we have succinyl-CoA is going to change to succinate. What happens here? A. Now what does A stand for? ATP. So over here, we're going to be releasing ATP, tamam? Using substrate level phosphorylation. Now moving on, succinate is going to change to fumarate. Over here, where are we? Dina, alpha. So there's an F, right? Over here, we're going to be releasing FADH2, صح? So keeping a tally, we lost 2 carbons here, tamam? Now we're going to skip the last step. It's just fumarate changing to malate. وآخر issue we have Na. What's Na? The last one is the N. NADH is released. This is the final NADH. This happens when malate is going to change to oxaloacetate. It's going to release an NADH. So we're going to keep a tally here. So now we have the products. We have 3 NADH formed, 1 FADH2, 2 CO2s, and 1 ATP. Okay?
And you can easily remember that if you don't, with the DINA alpha. So think about it. Decarboxylation plus CO2. No. NADH. Then D. No. Decarboxylation NADH. So how many CO2s? 2 CO2s, 2 NADHs. DINA ATP from the GTP substrate level phosphorylation.
So if you're in the exam and you need to draw the cycle to, for example, know the steps for the product, you can just use the first mnemonic, which is can I keep selling seashells for money officer, and the second one, which is D&D and Afana. And for the enzymes, there's the third mnemonic, which is cool arts and cancers, cells, special touch monthly. So for this one, it's just going to basically be naming out the enzymes, which you guys should know or memorize. So for the first one, as we know, the formation of citrates is going to be citrate synthase. And moving on, it's just going to be like CA for aconitase. Moving on, basically. Like you guys get the hint. Do you want to repeat it?
But someone's gonna do it right now, صح? يلا مين هيتطوع؟
طيب هسه we're gonna, someone's gonna volunteer. Someone's gonna try
Or
doing
I'm
it.
thinking if we have 2 boards,
Do
we have a competition.
Okay.
First. على فكرة we have cookies. فيعني الكسبان هياخد cookie.
اللي بيفوز باخذ كوكي، واللي بيشارك هو باخذ كوكي، عادي يعني. Okay. Where can we do it? We have, is this pen working? طيب I need 2 volunteers. Yeah, we need 2 volunteers. هاي بنخبيها عشان ما حد يشوفها. I'll just keep the. Guys, before we move on, does everyone get the hint? Does anyone want any repetition here? Like you guys will understand it? So you know how to use this in the exam?
What was the mnemonic again? For the, just the, in general. Can I keep selling seashells? For money officer. Perfect. And then for the products? Dina. Okay, perfect.
And the one for enzymes. Cookies? You want to volunteer طيب to get a cookie? المهم, it's cool aunts and cancers, cell special function.
يلا.
Alright, we need 2 volunteers.
أو أنا هختار وأنا مغمضة عيني فيعني volunteer أو أختار.
Guys, man, this is your way to test yourself for the exam. يعني لو حليتوها صح هسه خلاص.
خلاص.
We're gonna get a full mark in shot.
هم عايزيني أختار وأنا عاملة كده. أوكي؟ خلاص.
And students study the chocolate coffee.
ما هو أنتِ هتشوفي دلوقتي إن شاء الله خير.
طب في حدا they want to try?
طب إيه رأيك تطلعي مع friend؟ تاخدي حد. ممكن نعملها pairs. Do you want pairs? Pairs versus pair؟ يلا. أنتوا الاثنين؟ أنتوا الاثنين؟ pair؟ أنتوا الاثنين أوكي pair؟
Should we do
الإيه؟ لا اعمل اللي أنت عايزه.
Okay.
As long as you draw the cycle.
Because I memorize it.
Perfect. This is just a way to guide you. يعني أكيد you guys have your own methods.
Do you two want to try?
No.
لا هو he wants to try.
صح؟
لا he wants to grab him with you.
يلا.
يلا and then we need
Should
more
we
pressure.
play it tomorrow?
Yes, we're gonna have
start. طيب.
بس كل حاجة we want يعني enzymes, substrates, كل البرودكتس، okay?
Enzymes, substrates, and products. Exactly. أنا I'm gonna put a timer.
لا طب الاثنين اللي هنا انتوا عايزين اصل احنا نبقى على طول فيعني يلا. When we say go,
Should we give them 2 minutes?
لا اللي هو stop. Yeah, that's it. Okay. 10,
Okay.
9, 8, 7, 6, 5, wait, 4, 3, 2, 1, go!
جاهزين؟ Okay, stop.
Teamwork will give you 2 points.
I'm gonna leave it as 1 minute. So now it's at 20 seconds. 1 minute, 2 minutes.
And guys, by the way, we'll need 2 of you to check, to correct. ايه level of competitiveness مفيش حاجة.
طيب هسه wild card swap pens. swap pens يا جماعة. يلا اللي بعد هسه.
swap pens بسرعة.
swap pens. يلا. انت
لا انت لازم تمسك لا انت لازم اديله
side. Okay, for this one,
Yeah.
out of 3. Honestly, no, not 3, but I'll give it 2.
2.
2.5.
2.5 out of 3.
2.5.
Okay, now you guys are gonna.
التقييم إلى
ترجم لازم ترجم. It is not a cycle. I have to say this.
This is a bunch of.
Do you know the crab? مش crab هي crab.
But it's cute. Oh, jellyfish. Jellyfish. احكي لي ما حنشوف.
مالك
I have no
مالك.
I نزل
Okay, substrate is correct. تمام. Can you guys see? Can you move شوي عشان تشوفوا؟ تمام. So the substrates are correct. هسا عن ال products. I see a mistake already. لا خلاص كمل عادي.
سكواش. CO2. NaDH دينا. Perfect. وبعدين دينا. فين الأ؟
وين فيديو؟
Between A وال L
وين فيديو؟
لا.
وين فيديو؟
Between L. succinate. So البوزيشن بتاع ال ATP. فين ال FADH؟ What? Yes. ما هو that's the one that we skip بعدين from malate to oxaloacetate NADH. Okay. فين راح يوسف؟ لا نريد another judge. يلا تلس. الانزيم. في enzymes؟ في؟ حلو. طيب يلا تلس. Yes. كابو. Bravo. Yes, up there. Bravo. Humerate. بس they did more enzymes than you guys. So guys, all those in favor of this being the winning Krebs cycle, raise your hands. All those in favor of this being the winning cycle, raise your hands.
صوت عليك.
Wait, انتوا صوتوا ايش؟ نيوترال؟ لا ما فيش صوت ما فيش spectators. ها. And the winners are this Krebs cycle. You guys have cookies.
Good job, all of you.
Well done. What to command you have cookies for purchasing? Yes, let's remind us about it.
Okay. So, does anyone else want to try? خلاص? We all have this clear? Okay. So,
بس guys حفظوها دلوقتي يعني does anyone not understand anything in the TCA cycle? Spectators?
كل تمام؟ everyone on the same page? Okay? Alright, يلا. طيب, did we do this part? I don't think we did this yet. طيب, we're gonna have 2 questions and نكمل على آخر جزء, okay? So, the entry of pyruvate into the TCA cycle is inhibited by the presence of a high cellular concentration of A. طيب. Any other answers? Let's do a raise of hand. If you think it's A, lift your hand. Okay. If you think it's B, lift your hand. Alright. If you think it's C, lift your hand. And if you think it's D, lift your hand. طيب. The answer is actually B. Okay? So, can you tell me why you thought it was A? That's it?
No, it's because some of the reactions, like if there's a product, usually inhibits the.
So you know, in a sense, you are right, as it happens indirectly. And NADH, as we're going to discuss, it's basically a direct regulator of the cycle. Okay, we'll get to it now. And okay, طيب, we're going to move on to citric acid cycle regulation. So as we know, every single cycle needs to be regulated, right? Like imagine if it's left free, it's going to use all of the resources in the body, and it's going to heifer basically, okay? So steps 1, 3, and 4 are regulated, so they're known as the rate limiting steps. Why is that? Because if you control them, you can change the rate of products in the cycle, okay? So this is, so it happens in citrate synthase, in isocitrate dehydrogenase, and alpha-ketobutyrate dehydrogenase, okay? So they're regulated basically by 3 components, tamam? The substrate levels, the NAD plus and NADH ratio, and the ADP and ATPH ratio, tamam? So let me explain this in another way. So like imagine you have a car, all right? And the car is, you fill it with petrol, right? Tamam? So if you have a lot of petrol already, which means you have a lot of substrates, you're not going to want more, you're not add with petrol, so you're not going to put in more petrol because you already have substrates, and that's going to keep the car going, the car which is a cycle. Okay? So yeah, if you go to the petrol station and you have no petrol, you have then a lot of ATP, right? There's no petrol, there's no energy. You're going to fill it with petrol, right? You're going to fill it to the top again, which means you're going to make more ATP, which is the petrol, and that is going to help the car get moving again. Okay? After issue, the NADH and NAD, you guys know how the cars, they release like gas or waste products. So that's basically like the NADH. If you release a lot of NADH, which is not necessarily the waste, but it's going to be used, right? So you're going to have, like when there's a lot of waste being released from the car, which is the NADH, you're going to have to wait for the NADH to be used up first, okay? Get rid of the waste. And then you can fill it up with petrol again, or you can keep going again, which is NAD+. Yeah, it's kind of like just playing around with the levels in the cell, because this maintains the homeostasis, this prevents a lot of waste products from accumulating, this helps, you know, the substrates to flow in a natural way. Is this clear? Okay? Does anyone have any questions?
Yeah, I was gonna ask. So for carbohydrate metabolism, they kept insisting on the fact that we're using ATP and AMP to compare the energy levels.
Yeah.
Whereas in citric acid cycle, they're using ADP. So let's say in the test, if they instead of ADP it was AMP, does it change anything? It's still gonna trigger or it's gonna be saying that there's low energy level. But does it change anything?
So this depends on if we're referring to you're saying talk about glycolysis, huh?
I'm saying because
Comparing in general?
Yeah, in general.
Okay. Now the reason that we're using ATP here is because if you guys remember the reaction, there's a reaction of the GTP, as well as the ATP and ADP, right? There's a reaction that happens, and it's basically it's how to make either the ATP or the GTP. So that in that reaction they use ATP. That's why this is the reaction that's going to be regulating the cycle. But in glycolysis, they use AMP. Does that answer your question?
No, I mean here they say ADP,
Yeah.
whereas in glycolysis it's AMP.
Yeah. So in the exam, depends on what they give you. No, they're using different products. Well, I'm gonna have to refer to the textbook. I said this, and it just depends on a specific cycle. If it's like glycolysis or if it's the TCA cycle, because they both use different, you could say, substrates or different ways of regulating the ATP. Because there's many ways to make ATP.
In theory, both of them indicate low energy
Yes.
levels.
Yeah.
But if they tell you that this indicates this, just go with what they're telling you, okay? Inshallah, they're in good, يعني مثلا, for example, if they're telling you in citric acid cycle it's ADP, you're gonna find it in the choices. يعني لو هتحتاج ان انت تختار between AMP and ADP, just go with what they said. Okay? But as you said, both of them indicate low energy levels.
Yeah, but they're not going to go into these technicalities because this is like the specifics of the energy metabolism. Okay? Okay, we have 2 challenging questions in class today. So first of all, this one is saying, what would happen if the NADH produced in the citric acid cycle could not be efficiently reoxidized in the TCA cycle? Sorry, in the electron transport chain. Let me give you guys a bit of time. Think about it. And then we'll see. Is it A, where the citric acid cycle would stop working because NAD plus is depleted? Is it B, where it's not affected? Is it C, where it would increase glycolysis? And is it D, where it would switch to anaerobic metabolism? Give it a think.
Use the process of elimination. Which answers can you eliminate? And you go see
B or
this
C?
Is A correct?
Yeah.
A is correct? Okay.
only continue.
ATP production will be.
It will be
It will
effective, yes.
continue. Okay, طيب, so you want to remove B. طيب, how about C? Does this relate to glycolysis in any way?
No.
Okay, and D, are we going to go to anaerobic metabolism?
No.
Because this relates to lactate, right? So what do you guys think the answer is? A? Everyone agrees? So yes, the answer is A.
Can you say that D is also correct?
But in the
No,
presence of
because this is when you have no oxygen. Over here, it's when you have very high lactate or lactic acid. That's when it switches to the anaerobic metabolism. Yeah, if you have oxygen, it's always going to do Krebs unless there's a depletion in the substrates. So for example, the answer here is A because when you keep using NADH and you don't change it back to NAD+, it's going to get used. Because we're going to have no more NAD+, and the cycle can't go on because there's no NAD+ to accept the electrons, right? So this is part of the regulation, like NAD+, NADH. When one of them is affected or increases, this is going to affect the rest of the cycle. Tamam? Is this clear?
Yes.
Do you guys get the concept? Everyone? Anyone have any questions?
Spectators?
Is your question answered? Okay. But yeah, this one's easy if you guys memorize the cycle. Which of the following coenzymes is required by the enzyme alpha-ketoglutarate dehydrogenase in the citric acid cycle, and which substrate does it act upon?
D.
D. Exactly. It acts on alpha-ketoglutarate and it uses NAD+. Now there's not another answer, but what other coenzyme does it use? We said it at the beginning.
Coenzyme.
TPP.
TPP, yes. TPP is also used in this reaction. Tamam? It helps the alpha-ketoglutarate
Also
enzyme
niacin.
to
TPP is involved in which reactions?
Decarboxylation.
Decarboxylation.
Also niacin.
because this is oxidative decarboxylation, right?
Niacin also.
Sorry?
Niacin, nicotinic acid.
It also pays zero. So, okay. That's it for
Just
today.
refresh because there's a feedback form. Now before we end, هل في أي سؤال related to the TCA أو 9.1 كريدوكس أو كذا؟ أي أسئلة؟ Are we confident now with the TCA?
Aisha, have you not sure any concept you guys don't get?
How do you feel about the TCA sample now?
Me? No, I'm okay.
Good? 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 Spectators? Good? Good?
Everyone?
Okay, perfect. Thank you guys. I hope you guys did it. بس في feedback form بس we want you guys to fill it. Please before you just leave.
Yes. Thank you everyone for attending.
الكوكيز توع
So we can come and still in the basically. Guys, was this beneficial? Did it help you in any way?
Guys, these are matcha cookies that run.
Yes. Thank you guys for participating and thank you for attending. And good luck with your upcoming quiz. When is your quiz? Next week? Monday.
ربنا معاكم يا رب ان شاء الله ان شاء الله ان شاء الله it's going to be a lot better than the other one بإذن الله. The recording is still on?
Still on.
لو في اي اسئله guys please message us وربنا معاكم. If you need anything at all we're here.
Thank you everyone. Have a lovely day. Good luck. Yeah.